Alright, so we are graphing sine and cosine equations today. This is just 10.1, and we're only going to be worried about the sine and cosine graph in terms of the amplitude and the period. As you may remember, our sine and our cosine graphs, they look like wave functions here. Alright, in which they will just be going up and down forever and ever, on and on. These wave functions are also called sinusoids. So to graph both cosine and sine functions, we're going to be using our handy unit circle to fill out for our, given our x values, what our known y values are. From our unit circle, we can remember that cosine is the x value of the coordinate on the unit circle, and our sine will be the y value of the point on the unit circle. So when we are at 0 on our unit circle, we are at the coordinate 1, 0. So for cosine, 0 has a value of 1, and for sine, 0 has a value of 0. When you're at pi over 2, come over to pi over 2, our x value is 0, our y value is 1. Then go over to pi, x value negative 1, y value 0. And so on down the line. 0, 1, negative 1, 0. So we're using our unit circle to create some key coordinates for being able to graph sine, cosine, and tangent. Now, graphing each of these are what would be our parent function. So this is our function in standard position with no changes or anything to it. So first I'm going to graph my cosine. I'll just carry over our values from above. 1, 0, negative 1, 0, and 1. So our cosine graph, when we're at 0 here for the x, this is our theta. Y will be our f of theta. So at 0, we have a value of 1. To make this a little more obvious, I'm going to call 1 all the way up here. So 0, we're at 1. At pi over 2, we have a value of 0. And then at pi, we got to go down to negative 1, which we'll just say down here to make it a little clearer. At 3 pi over 2, we're at 0. And at 2 pi, we're at 1. Connect these all up, and we get a wave. So our wave starts here at 0, and then our wave finishes at 2 pi. In between, we have a halfway point at pi. That's halfway between 0 and 2 pi. And then we have one more quarter point at pi over 2 and at 3 pi over 2. So for each graph, you got to have 5 key points for graphing it. For our sine graph, we were at 0, 0. Pi over 2 is 1. Pi is 0. Negative 1 and 0. So when we graph that out, this is f of theta. This is theta. So we would be at 0, 0. Pi over 2, we go up to 1. Back down to pi. Then to negative 1. And then back to 2 pi. Again, we make a wave. We still have our 5 key points. Halfway, halfway. The difference here between cosine and sine. Cosine, we start at the maximum of the graph. For sine, we will always start at the origin. And these are for our parent functions. Alright, for today though, there's only going to be a couple translations or transformations. Same thing we did in chapter 5, chapter 6 there. Now to do that, our standard equations for cosine, there's an a value and there's a b value. Same for sine, we have an a value and a b value. The amplitude is the maximum displacement or distance moved by a point. Amplitude will be our absolute value of a. Another way to think about this from our transformations is this is the vertical stretch, or vertical shrink actually. Our period, that's where the b value comes in. That's going to be 2 pi divided by b. This another way to think about it would be our horizontal stretch or our horizontal shrink. Alright. And last we have the frequency. That's going to be b over 2 pi, or basically the inverse of your period. All of our graphs here, the amplitude and the period is what's going to be changing for today, and that's all we're going to worry about. So a couple example problems here. If I have a graph and it's 3 sine of 2 pi. All right, first thing we have our a value here. So that means my amplitude will be the absolute value of 3, which means my amplitude is just 3. So my max will be at 3, my minimum at negative 3. The period is 2 pi over b. Well, if b is 2, that means my period is 2 pi over 2, or my period will be pi. What that period means is that if I'm going to start at 0, I'm going to finish the entire sine wave by the time I get to pi. So that means all 5 of my points would be between 0 and pi. Last, my frequency will be 1 over pi. So now for plotting out my sine graph, I need to put in my maximum, 1, 2, 3, at 3, and my minimum, 1, 2, negative 3. So the entire wave will occur between 3 and negative 3, and the entire wave, all 5 points, will start at 0 and will finish at pi. So halfway across would be at pi over 2, and my sine wave, we go up, and then we come down, and then we'll finish here. So I got to go all the way up to 3, and that is halfway between 0 and pi over 2. So I'll go all the way up to 3 like that. And then for the minimum, I got to come all the way down to negative 3, and that would be halfway between pi over 2 and halfway between pi over 2 and pi. So we'll go all the way down to negative 3 and connect it to pi. In each of these waves, they'll keep continuing on over and over all the way to the end. So there will be another one from pi to 2 pi. Take our halfway, mark off our points, and we will go 1, 2, down to negative 3, and so on. And it'll continue also in the negative direction. All right, the second example, we have a cosine graph, and this is a 1/2. It got cut off. All right. So for cosine, we have an amplitude of 2, or negative 2 in this case. So that means my max will occur at 2, my minimum at negative 2. Now this negative sign right here, hopefully we can still remember from earlier, the negative means we have a vertical flip. Now that vertical flip means that instead of starting all the way at the top, we're going to actually start at our minimum value. So we're going to start at the minimum. All right. Now my period, I'm going to have 2 pi over b, or 2 pi over 1/2. That's going to be the same as 4 pi, which means my frequency will be 1 over 4 pi. Now for all of these, I'm still starting at the origin. Now since it is a cosine graph, that means I do not start at 0. Normally I start at the max, however it is a vertical flip. So I'm going to come down here to negative 2, and this will be our first point. And then our maximum's up here, positive 2. My period is 4 pi, so that means when I start here at 0, my finish would be all the way out here at 4 pi. Now that's not all the way on my screen. Halfway between 0 and 4 pi. This is my halfway point. All right, which means this would be my quarter point right here at pi. So halfway, quarter. I'm going to finish all the way up at a positive 2. Quarter point means I get back to 0. So this is my first half of the graph. I need to be able to graph the entire thing, and I haven't graphed the full period, so I'm going to have to go to the negative to have a negative 2 pi, because from negative 2 pi to 2 pi is a positive 4 altogether. Mark our quarter point. At negative 2 pi, we're going to be a positive 2, and then we will connect all the way. So this is one period length. All the way from here to here is one period length of a cosine graph. All right. So those are two examples for you. The same rules apply for all the others at the moment. So for today, your class practice problems just on the back there would just to be try numbers 4 through 12. And we will continue the rest of the packet when we get to class on Monday.